Hi everyone, this is Mr. Nam again, and today what I'm going to do is I'm going to be going over your lesson for Friday, October 9th. And today, guys, we're going to be talking about how do we graph the solar system accurately. Okay, so your bell ringer for today was reflecting on it. What are some types of graphs that you have used in science or math class before? I know there's a lot of graphs you use. List them in there and tell me what you use them for. That was our bell ringer for today. So if you didn't do that, just make sure you list that in your digital notebook. Okay. Kind of our gathering question for today was just, would you rather travel back in time to meet your ancestors or travel in the future to meet your descendants? Okay, just a question to kind of get your brain going. So feel free to just think about that. But we talked about this as a class. And then we dove into our learning target. And that's stating that you will be able to accurately graph the relative size of the planets in the solar system. Okay. Now we talked about the relative scale yesterday. Today we're actually going to graph. Okay. And then the essential question, guys, is how can we compare the sizes of the planets? The planets are all very different sizes. How can we compare them? Okay. You had two vocab words today, guys. The first vocab word is weight. Okay. And this is a measure of the force of gravity on an object, usually measured in newtons. The greater amount of gravitational force acting on an object, the heavier it is. Okay. The more mass it takes up, the more space it takes up, usually the greater its weight is. Okay. And then second is telescope. We've all seen telescopes, but what telescopes are is they're instruments that make distant objects appear larger and brighter using lenses and curved mirrors. Okay. The planets that we see in space, they're really far away, but they look huge in a telescope. It's because of the way that a telescope uses curved mirrors and lenses to give us a clear image. All right, guys, in your digital notebook, and I believe, let me go back to our digital notebook. We are on slide 17. Okay. What I want you to do first is I want you to watch this video, and I want you to summarize how we can recreate the solar system in real life. How can we do it? Okay. Watch that video on your own, and then you're going to record that in your digital notebook. Okay. And before we head into breakout groups, your next thing you were doing is I wanted to give you your rapid idea. So this is in your digital notebook on slide 18, okay, is your rapid idea to start. Okay. And your rapid idea, guys, oopsies, is stating that the solar system is mostly filled with empty space between the planets. Okay? The mass of a planet is determined by its gravitational effect on other planets. So we talked about size and scale yesterday, but now today we're really going to dive into mass. And how do we determine the mass of a planet? Some planets are made out of gas. Other planets are made out of solid, but why do they have different masses? Okay. Then what I wanted you to do in your digital notebook, your own thoughts, you are going to watch this video and answer in the chat for me, how did we figure out the Earth of mass, the mass of the Earth, okay? And also if you are watching this and doing this on your own, just type this answer right below this question in your digital notebook, okay? And then what you're gonna do, guys, is then I put you in breakout groups, but if you're watching this, you're doing this on your own. But what you're gonna do is you're gonna drag and drop these three types of graphs. Okay, we have line, bar, and pie graphs. Okay, for each of these, you are going to drag. Okay, purple means good for, blue means used to. Used to, what is it used for? Okay, so for these three graphs, and the name, as you can see, is in yellow. I'm not saying these are oopsies, that these are the correct answers, but I am just dragging to show you examples. Okay, let's back up a bit. Okay, guys. After that, we pretty much wrapped up class, but I wanted to go over your assignment for today because your assignment today is a little different than what we normally do. It is in Google Classroom, and it is called Graphing the Solar System. Okay, and so in this assignment, guys, the first thing you're going to do is you're going to click on this image here that's going to open up a link. When it opens up that link, what you're going to do is you're going to use the planet's mass relative to Earth. Okay, so if I go here when it loads, like the internet always taking its sweet time. Awesome. Okay. So now what I'm going to do is I'm going to scroll down, and I'm going to scroll down here. I'm going to read through this and see, okay, what is my mass on a different planet relative to Earth? As you can see, on Earth, I'm 110 pounds. On Mars, though, I'd only be 42 pounds, even though the masses are the same for each planet. Okay. So what you're going to do is you're going to go down to this table down here, and you are going to look at each planet and look at this column. Oopsies, that says each planet's mass relative to Earth. Okay, so for Mercury, my planet's mass relative to Earth is 0.0553. So what I'm going to do is I'm going to go to this table and type in the relative mass is 0.0553. Okay, and I'm going to do that for each planet. Okay, and once you have that, what you are then going to do, okay, is you're going to go to this next slide. So this next slide, what I'm asking you to do, okay, is determine the Earth. You're going to then graph the masses of the planets in relation to Earth. Okay, in relations to Earth. This is where it gets a little tricky. Okay, as you can see, Earth, I gave you this example as 1. And I kind of give you that. And if you go back to up here, I'll give you this hint. Earth's mass relative to Earth is going to be 1.0 because that's a 1-to-1 comparison. Okay, but now let's say I go and I'm going to do an example for you. Okay, let's say I go to Neptune. Okay, and Neptune, let's say, is 17.1 in terms of mass relative to Earth. I'm going to go to Neptune. Is that Neptune? Was that Neptune? I'm sorry. Neptune, yes, 17.1. My bad. Neptune is going to be 17.1. Okay. Then what I'm going to do to graph is I know, okay, Neptune's bar has to be about 17 times larger. Okay. This is tough to graph given the scale of this chart. This is hard. But what I'm looking for is for each bar that they are just relative to each other. Okay. So like, let's say this is, if you say this is 17, oopsies, 17.1. Okay. That's just an example for you. Let's make this font a little smaller. 17.1. Why is it not typing? 17.1. Okay. And then if I went back and let's look at another planet. Okay. Saturn is 95.2. So if I go to Saturn and I type in 95.2, right? I know that my bar for Saturn needs to be 95.2 times larger than Earth's. Okay. So I might do, it's really hard to do this to scale. Okay. But let's say I do, let's just assume this is 95. Okay. Don't worry about this down here because this is, I'm going to delete that actually, because that's making it hard for you to actually tell the difference, okay, in terms of relative scale. This is hard because we don't have exact numbers and an exact type of measurement, but I want you to kind of guesstimate and just use your relative size of your bars to show the different scales and relative masses of each planet related to Earth, okay? After each planet too, make sure that you go ahead and type the actual number, so 95.2, okay? But I'll make the font smaller for all of these, okay? Like always, guys, if you have any questions, let me know. But this is your assignment. Once you have graphed it and filled in this table above, you can turn it in and you'll be done for the day. Okay, if you have any questions, let me know. If not, have a great weekend, guys, and I will see you on Monday.